Hello everyone, and welcome into another live stream. Yeah, I'm just starting right away. No point in waiting. The reason being that I'm, as always, starting unprepared. Or maybe I should just... There we go. Flame already... Flame already saw it. Hi, this CP. Hi, Happy. Hi, welcome. Hold on, let me just... wait, I wanted to prepare something. I don't remember what though. Oh, I remember now, okay. So hello everyone, and welcome into another live stream. Today we'll be streaming with Tefta. Did I mention that? Did I include in the thumbnail? No, I didn't. I have to remake the thumbnail. Shucks. We'll be streaming with Tefta. That's everyone's favorite kind of stream. What's a PCB? I don't know what it means actually. It's a board. That's all I know. All I know is that it's a board. Yay Tefta stream! Yay Tefta stream indeed! Hi the Tefta!
Hey, how's it going?
I love how everyone right now is excited for Tefta streams. That's the best kind of live stream. And this is gonna be a strong one. Because this is going to be... well, it's not good. Whenever I stream with you, I always feel like this kid in like talking to a teacher one-on-one. We're like, recently we've been streaming a lot, and the first stream was basically me learning about like AIs from you. Second one was me learning about philosophy from you, and the third one right now will be me learning about PCBs from you. So hi the watch Nana, by the way. Hi.
That's funny. I usually try to surround myself with people that know a lot, and it's fun because I'm always feeling like I'm a state of being a student, just because I'm always learning stuff from my friends.
I
also have a cold, if you can't tell.
Yeah, I can tell. I was about to ask you if you're feeling well.
I feel good mentally. It's just my nose is stuffy.
Okay.
So I feel 100%.
If you feel good mentally, then that's grand. I'm sorry, I just moved. There we go. Well, then I don't know.
Hey, watcha.
PCB means physics, chemistry, biology. Precisely, that's what we'll be doing today. We'll be doing physics, chemistry, and biology. For those who don't know, although you should know by now, at this point you should know, but for those who don't know, Tefta, in his free time, his hobbies include like making open source prosthetic hardware and software, saving the world, and also designing PCBs as part of the whole hardware software thing. That's why I thought it would be a perfect kind of live stream, because wait, what was the name of this application used to design PCBs? I know I have it on my PC.
KiCad or KiCad.
KiCad, there we go. Yes, I have it.
Popular.
KiCad can anonymously report crashes. Design. Yeah,
I love KiCad because it uses relative folders. It's kind of cumbersome when you start to build your own footprints and symbols, but it does it in a manner that you can upload it to GitHub and other people will have access to everything.
Oh, that's really...
So KiCad is my favorite. Literally without it, I couldn't do what I'm doing.
I just love how whenever, when it comes to both programming and design, basically working on hardware and software, there's just like so many free programs. I just love that fact so much. Where you have genuine because KiCad is an amazing tool if you think about it. It's really an outstanding.
It is seriously amazing.
It also
they even have now
right? which
I'm not sure about that.
Well, I've
never used it.
I think I used it once. Okay, we have calculators, basic. Convert bitmap images to schematic symbols. That's cool.
I'm trying to learn FreeCAD too, because I want to put all the OpenMuscle stuff in FreeCAD, so everyone would have access to even the design files for the 3D printed parts. But that's a slow process.
Wait, 3D printed parts? Can't you just upload STLs, or do you mean like?
You can, but like when you're designing in CAD, you're hopefully using a parametric design.
Oh yeah, yeah,
So
okay, I get it
other
now.
people, they would actually have the ability to modify it. True, you can modify any STL file, but if you could actually give them the raw file, it's like giving someone a compiled program versus the open source.
Yeah, yeah, yeah. I mean,
So
I know how
STL would be the
parametrics.
compiled, yeah.
Mm. I know because technically Blender does the same thing, where if you export to STL,
Yeah,
all the things get applied, and if you have modifiers in Blender, which is minor, geometry nodes, which is a much better way to do parametrics, but also I know Blender isn't for parametric stuff, and I know when it comes to parametrics, this is quicker to make schematic things. But
yeah.
I'm just doing visuals, so you know, I'm most of the time I don't worry about doing things smart. No, I just do things and they sometimes work out, sometimes they don't. Oh, yeah, the reason why I'm making PCB today, by the way, is because for the first time in my entire life, it's you know how in different fields of science, there's always like this first time thing. So, for example, in chemistry, you have your first chemical reaction, right?
Yeah.
In math, you have your first differential equation solved, or maybe first problem you calculated all by yourself, right? The first original approach you took. Well, I just went through my kind of engineering sort of first step, which is for the first time in my entire life, I got the transistor to work, which
Yeah,
it
yeah.
was way harder than it sounds. But I have it set up, so right now, and I've tested it. Yeah, I prototyped it with the power supply. That was really smart, and then I actually switched it to the Raspberry Pi and worked. How to start making things? I already know programming
Uh,
Python and C, so I'm pretty good at respect. But how do I learn how to do all design electronic stuff and putting it together? Tefta, would you like to take the first? Because I feel like you have more expertise in this than
Yes.
me.
So I answered. I said I would suggest a microcontroller and a blinking LED. But yeah, because if you can have like a breadboard and make a blinking LED, either with a microcontroller or with circuits, I think that's like the first place to start. Usually the 555 chip is, but I use MicroPython because of its ability to rapidly prototype.
MicroPython is
And
really
so
good.
I love MicroPython that runs on microcontrollers. I think it's just amazing. And you can also use C types. So if you need to program fast, you can use the library
Yeah,
to literally run C code.
programming fast things because it's not really even programming fast; it's programming faster things than MicroPython. So when you actually need to program fast things, that's when you're really. I would say that if you actually need to optimize for speed, that's how you know you're actually no longer a beginner and you're getting into the advanced things. So I would say MicroPython. Just also, I would recommend the Make It
It's
way,
awesome.
which is just disrespect the field. I always like to call it that way. So basically means no, just pick a project. It doesn't matter. It may look way too difficult. Just pick it and do it. Just pretend like it's easy. Just repeat to yourself
Yeah,
that it's
seriously, just
easy,
do it.
and then just do the project. And at some point you'll just like forget that it's a difficult thing to do. You'll just do it, and then you'll be like, oh my goodness, I forgot it was difficult, and then it'll be finished. So you know you don't have to worry about that. I managed to do
I
some
have a friend
simple.
that's going to electric engineering in another state, and he's learning all this stuff, and it's kind of cool to see his excitement because it is pretty darn fun when you get a transistor to work. It is
Oh yeah.
amazing.
By the way, I've got this. Oh, turning on the transistor. It's such a pain. And it's honestly
Yeah.
witchcraft. Like, Tefta sent me a circuit, just straight up a circuit of which I was just was the copy, and it was tried and tested circuit for transistor, and it didn't work. And the reason why it didn't work is because transistors are magic. Well, they're not magic. They are quantum mechanics, which is the same thing. And because of that, like you basically, oh, it's something that's something that right now I'm working on explaining electricity for electronics video, and I'm doing a bit of research for that. And so I'm getting into the quantum mechanical, chemical, and the practical levels of electricity all at once. And I understand why things like Ohm's law exist, for example. I get it. It's more convenient, but I really don't feel like people should be taught this way because it leads to a lot of confusion. Like, for example, people learn that the only circuits that actually work are closed circuits, right? Which, yes, in practice, that will be almost all the time. That's what's gonna happen, right? Only the closed circuit will actually work. However, the individual electrons don't know if a circuit is closed or open. Like
so you just have a light year long cable, right? And then you just run the circuit, and it's never actually closed. But since it's a light year long, it will still run until it figures out that, oops, it's not actually connected.
Precisely. And this might seem
you
like
probably have to use a superconductor though, so there's no resistance because of infinitely long wire will also. But yes, it technically would work in an open circuit.
Yeah, because if you
with
think
a
about it,
superconductor that is a light year long.
Yeah, if you think about it, like technically everything is a closed circuit. Like you can have, I don't know, well, technically almost
it's
everything.
Abstraction.
Except
we don't understand it. I think it's just an abstraction that's useful, and that's why.
Yeah, that's what I mean.
Even
that's
when
why
you
I said
fully understand
the
knowledge of humans of electronics, you're like, well, they don't even really know how it works. They're just, this is the best way of predicting how it will work.
Yeah, but yeah, and that's why I started this by saying, like, I get why Ohm's law exists, and I get why it's useful, and I get people should absolutely learn that, you know, only closed circuits work. It's just that they should learn the rule of only closed circuits work only after, you know, explaining why closed circuits work, because then you'll realize that there are exceptions. Those exceptions may seem minor, and exceptions and modifications, I would say. So, for example, picking a path of least resistance. It's not like the path of least resistance is pulling electrons. Electrons are pushing in every single direction, and they'll just happen to pick the path of least resistance. That's why, for example, in the circuit, I'm going to, yeah, so let's schematic it, I think, first.
Yeah.
So that's why, and that's going to be great for this circuit I'm going to show right now, because the circuit I'm going to show right now, if you just like use these really abstract laws, it wouldn't make sense for only this configuration to work. Hold on, let me just bring it over. Bring over the two breadboards I have. Make sure that I don't screw anything up. Like this, not like this. Blue and yellow.
Someone's talking about uranium-235. Yeah, uranium-235 versus uranium-238.
I have it on two breadboards. Because I'm sorry if you started talking, I just didn't see you. I'm used to recording now whenever I do things, and I'm used to walking around my office and just screaming, so the microphones can pick me up. But okay,
that's hilarious.
All right. I'm not used to this. So this is actually the one you sent me, except I modified it because the two resistors you included. They were working as a voltage divider, and the Raspberry Pi actually didn't have enough voltage. I removed one of the resistors to
the one resistor was just to protect the microcontroller, and then the other resistor is the drain resistor. I don't know the proper name for it, but it's meant so that way the transistor doesn't act like a latch.
And that's precisely what I mean, because that resistor does not make sense if you just do the highest abstract rules. If you just do those, then it doesn't make sense, because it technically is still conducting. Technically, you have a closed circuit. It's all fine.
Yeah.
Okay, so
and then it's just like a latch. But sometimes latches, I'm actually trying to build a latch for my next PCB, so that way you can just have one button that turns on and off the device.
Oh, hold on.
I need to blow my nose. 1 second.
All right. I'll don't worry. I'll just try to figure what I'm doing. In the meantime, use millimeters. I don't like using inches. It brings back bad memories. Mil. Wait, mils? Where are mils? Hold on. Are you gonna do some calculations? I don't know. Actually, I don't really. I don't think we'll need to do calculations this time. Because the circuit works and it doesn't really matter all that much with the exact numbers. Normal way, isolate uranium-235 from ore using cyclotrons and beryllium core to jumpstart nuclear reaction and explode. Make it way. Consider it easy and steal the nuclear core to explode your target. No, make it way would be just, you know, don't think about it too hard and just do the chain reaction. Pretend like it's easy. It's gonna be easy. Then for the first time you're doing something that I've also been like 3 economic assignments do in 5 hours. Mate, that's the assignments. It's not gonna disappear. I'm gonna turn the whole video. Don't worry. Do not worry. Okay, I'm fine. I can figure this out.
So it's funny that later today I'm gonna be talking with a friend helping me with my coffee clicker invention. I think I shared you the image of that in Discord.
Wait, coffee.
But it's funny that, yeah, because I don't know if I told you, but I invented a new device. So, and so I'm working on it with a friend. He's gonna help me with it. Did I tell you about that?
I don't remember. I don't remember honestly.
So you know, I go to a think tank, right?
Yeah.
A whole bunch of smart people. We get together and we try to talk. Well, anyways, we talk over one another whenever we have a heated discussion. So I invented this device that everyone will have, and then we can do a vote really quickly, and we can also request to speak next, and it will also time people, because when you got 12 people in a room yelling at one another, it's not cohesive. So this device was meant to alleviate that.
Oh yeah, I get it.
So I sent you a picture of the PCB. Yeah.
I mean, we talk over each other all the time, and that's just the two of us. I can imagine how 12 people that would be. Must be chaos. That's a phenomenal idea, actually, and it looks so clean. Damn it! I want to get to that level one day. We're like, you know, as a
and it's.
Can I show on the stream?
That's the circuit that I gave you. That from this, that's what I was working on. That I tested this circuit for the N-channel MOSFET.
So wait, can I share it on stream?
Yeah, and so I was, of course, yeah. And this is also what I'm doing for fun. So it was just it was funny that Make It was asking, "Hey, I need to do XYZ." I'm like, well, I'm kind of doing that. But you also inspire me to work on like my own ESC. So
I'm like a mascot, so you know, I'm happy with that role. I like it.
But see, that's the haptic motor. So that vibrates, and we joked this last think tank meeting that let's have it shock the person. So I'm gonna add headers and like a add-on on the bottom so we can actually shock people if they're talking for too much. I think it's gonna be awesome. You should definitely help me with that.
I actually, funny enough, now you mentioned, I will have to get into how to make sparks with electricity. So. But that's a Patreon only thing. There's one thing which I really want to share about when it goes to so 25 patrons. I'm gonna make it builds a weapon episode 2, and here's the thing. I know that in comparison to my other videos, it won't have such a deep meaning behind it. Like, you know, in each video, I like to add like a nugget of depth to it, right? So for example, will be a good example. The best one, addition to quantum mechanics, the biggest video on channel. The whole point was, don't be scared of quantum mechanics. It's just like classical mechanics. There's always this nugget of depth. When it comes to make it build a weapon, we don't have that. I'm just going straight for fun. That's it. And I came up with such an amazing idea. Such a phenomenal idea for it. I will share it on Patreon only Discord because I just can't keep it in me. I'll just have to show you because it's so phenomenal. I know I'm
excited.
I know I'm doing like a huge sell, but this time I don't regret it at all. It's gonna be amazing. It really is. Yeah, I'm gonna end this.
As long as there's a payoff, then yes.
Yeah.
That's awesome.
Hold on, how do you even work this thing?
So what are we working on?
Oh yeah, right, they're on the side. That makes sense. Yeah, so wires. So let me first do the circuit.
And then Sleepy said that you're not paying attention to the chat.
I'm
I think I
half
saw
paying
that.
attention. It's hard to pay attention to like two different active channels at the same time. I mean, I am paying
Well,
attention.
I'll read them for you.
Uh,
It says, "Not make it just ad and can't focus on the comments." JK.
you know how
I'll help you.
Meadow
I'll be
Labs
your
has
helper.
like a bot to read the comments when he's working on something?
Oh,
Yeah, I should
yeah.
really get that sort of thing.
Yeah, I got TTS. There's some free ones that I use.
We could make our own. We're professionals. And I shouldn't
True.
say we. I'm that's a very bad habit of mine. I'm like hooking people into stuff without their consent. And you know, when
Oh, yeah.
normally many people do that sort of thing, and I think that's fine, but because I'm doing it publicly on stream, it adds more weight to it, and I don't. That's pretty dangerous. As I'm seeing you
Dangerous.
for the first time.
That's a powerful weapon you
Yeah.
wield.
Powerful, you know, with a lot of power comes a lot of taxes from, yeah. Numbers don't remember here. Mike, are you? I feel like Mike. I feel like you're trying to pick a fight. I just gotta say it, put it out, okay? Because life projects show way practicality, hence here's the aluminium where it's slightly different than initial. What are we talking about? You know what? I'm just gonna do this again. So yeah, we have a battery. I said we have
Okay.
Okay, sick.
And that's a 3.7 volt battery, or what are you using for the battery?
I think 3 point. I don't have a
Because a
memory.
normal single cell battery varies in between 4.2 volts and 3.7.
I'm just gonna.
So when it's fully charged, it's usually 4.2.
No, I feel like that's.
And then like double A's are 1.5.
Nice. Oh. So it's I'm back. Does it say on it? It says 3.7. Yes, 3.7 volts.
Sweet. So it's a single cell.
Okay. So wait, how do I end the thing? End. Finish. Done. Finish wire. Okay, there we go. That's how you do it.
I should give you a list of like 3 things that I'm starting to stock up on for my simple electronics. I'll have to send you that list because I use these LDOs. Like a LDO is a down converter. Since most microcontrollers are 3.3 volts, it literally is like just a really small transistor thing that you put in battery voltage and it outputs a steady 3.3 volts. And its inefficiency is radiated off as heat. But with that, you can make the super simple circuits. You aren't going to charge the battery or anything, but so I bought a whole bunch of those.
That does sound like something
And then
that would be come in handy.
yeah, and then N channel MOSFETs, and then a battery charging circuit with 5 pins. So I might just send you that list of 3 things because that's kind of I'm still learning this process too.
I mean, that's why
those are like
that's why
the
I
most useful
like
for me.
that's why I like having expert because for me I would just waste months like with trial and error every single time waiting for the deliveries. Also, that's why I
It's nice when
also
you have someone.
that's why I asked you about the MOSFETs because right now I ordered I think 20
Yeah,
of them, just because you know.
nice.
I thought if I'm
Nice.
ordering mine as well, so I'm really glad it worked because if it didn't, I would have 20 useless MOSFETs. Well, not useless technically, but with no use to them. Make it there is no Sodakisi music today. Yes, there is no Sodakisi music because whenever I play Sodakisi music, I have to quiet down the desktop audio, and I just have Tefta on today, and I don't like quieting down Tefta. Hold on, any tea in y'all just have to behave. Okay, so we have this. Then how do I add a MOSFET? There should be like
So you want to go to tools. You want to add. So it's also the symbol right above the ground symbol on the right side.
Right
on the very right column.
Oh, this.
Right.
There we
go. No, on the very right column. Yep. The top right above the ground symbol.
I can give you
it's third
a
from the
stream
top.
on Discord, by the way.
Yeah.
There we go.
Oh yeah, that would be helpful.
And
Watch stream.
MOSFET. I don't want a specific one. I just want an N MOSFET. Just this.
Yeah, so it's actually a little bit more hard to search. You want to find the actual component.
The actual component?
So yeah, like what's the name of the component? Like that might work too. Never mind. Don't listen to me.
I mean, the name of the component would probably be better. To be fair, okay,
Yeah.
this is a bit large. Oh, I love it when the movements are intuitive. I like that. Right, so let's move it here. Can I rotate it? Oh, phenomenal. So the way it works is we have gate, drain, source. So this is the gate. Oh, I hate it with that there is like no... Oh, damn it. I don't really like
What?
how they're really often in the documentation of this MOSFET. Gate is the first pin. And that
Oh,
really screwed me over a bit. I mean, I didn't get it wrong, but it really made it hard to like figure out what goes where. So the negative will go gate drain source. Negative goes to source. Source is this one, so 3 right here. This is negative. There we go. That's where the negative goes. This will also go to the ground on the microcontroller. I don't know how to do professional. I'm gonna remake this circuit 3 different times.
so here, how about this? Go click on the ground symbol on the right again. And then, yeah, so then open up the power tree under items. And then, yeah, so click on, scroll till you see plus 3v3. Yeah, there you go. Click on that. 3v3, hit OK, and just put it on the right side.
Like here.
Put it randomly anywhere. It doesn't matter. Click, yeah. And then click again where you were doing for the power symbols to get the ground on the right.
So click just anywhere or
Same where, no, click on the ground icon again on the right side. Or yeah, click anywhere. I think both work. Perfect. And then scroll down till you see GND for ground. And then put that somewhere.
okay,
There you
so
go.
ground. I feel like right
Okay.
here.
Now you have those. You can copy and paste them. Yeah,
Oh, that
that's
is
what I usually
convenient.
do. So you can copy and paste those
Wait,
wherever you want.
then might as well actually do 3v7, unless there is no 3v7. There's no 3v7.
There isn't, but you can
3v7.
3v8.
That's
Well,
close enough.
3v8 is probably better because 3v7 might be too low. So that would be your battery voltage. Yeah.
I never understood really the difference between ground and negative. I know that when it comes to calculating the circuits, ground matters, but I've never learned why it matters. It's like used as a reference. I feel like just ground would be good
Yeah.
enough for this, unless I'm right. Just ground.
Yeah.
Because this goes both to the Raspberry Pi ground and it goes also to the battery negative. So this can just be the ground.
Yeah.
Yeah, there we go.
Exactly. The only time you really have to mess with different grounds, yeah, it's rather rare, but
It's from what I've seen. I remember back in my good old circuit solving days, just like used as a reference for plus or minus. It's so confusing. I gotta dip. Do I will see buy ram it buy?
see ya. So your 3 is your source, right?
Yes. So here, okay. I'm looking at the cables, and also I'm just connecting random cables. I don't care about the colors at all, which is making it, as you can imagine, pretty easy to follow. Wait, so this is the ground. Also, the ground then it's connected with a resistor. So, wait, is resistor? Can I just like a normal one?
Yeah, just the letter R. The letter R.
That makes sense. There.
That's all you're looking for.
All right. So
Yep, there you go.
resistor, which goes from the ground to the. This is gonna be fun. From the ground. So right here. Wait, no, on the other side. I'd rather actually. I changed my mind. There. This goes.
Oh,
Connects.
and you got to be careful because it's the left side is now connected to that wire. By the way.
Oh, so this side.
If you
Oh,
move the
that's.
resistor,
Oh, that's a really
because
good
it
catch.
connected it.
That's a
Yeah.
That's a
yeah,
really good catch.
stuff like that can ruin your day. And yeah. I've ordered PCBs and they take forever to get there, and it's just like, oh, look at me, I made a stupid mistake on my schematic and gotta wait another bajillion years.
Okay, now this gets connected to the gate. Oh, never mind then. I should have actually, you know what? I take it back. I actually rather get this way, because this we connect to the gate, and we also connect it to the cancel. We also connect it to the
Yeah, and so what you use is it's the little symbol that looks like an A with like a shape around it. That allows you to create the name of a destination, like say battery plus. You can type in whatever you want,
oh, it's like
and
in
then it will yeah. So input perfect. So if you have two of those, one on your microcontroller and one on the pin 2, they'll connect each other as if there's a wire connecting. And it's
oh,
really nice to use this feature.
okay.
So yeah,
This will come in
it's
handy
good for
soon,
labeling.
because
Very yeah.
right now I
But
don't need
you're,
it, but soon
I would
I'll,
okay.
because right now I'm just going to put literally just that's bus. Well, technically yes, but in practice I'd rather do it with a wire. So like this, and then the source. Wait, no, that's the drain. The drain goes to the drain goes to the, oh, right here actually, precisely what you just mentioned. Right here is where the A
Yeah.
will be phenomenal, because that will be the motor right here, and then
Yep.
the other motor will go right here. Wait, can I tap in motor again, or how do I do it?
You can, but they'll connect to each other. So
Yes, I do
you'll
want
want to
them.
name them something different.
Oh, I do want them to connect, because this is
Well,
the one side the motor, and that's the other one.
negative. That's the other. So I would name one motor plus, one motor negative.
That is smart. Okay, now right
Because
here.
and you have them reversed, but that's okay.
Oh yeah, this is plus. Well,
Yeah,
okay.
yeah.
That is once again. Okay, so minus motor, because here comes the negative, and then right here we'll have a plus motor, like this. There we go, and that's it. That's walks.
Yeah, make it streams at random intervals, so you
I
gotta
really
kind of
do.
catch
I really,
Robin
but
Cat.
once again, I stream literally every day. So if you all miss a stream, don't worry about it too much. You can always catch the next
There you
one.
go.
You know, streaming at random intervals is a
Motor
blessing
negative.
and a curse. Because if I was streaming at precisely the same time each day, then if it was misaligned with someone else's schedule, then they would never join in. Absolutely never. But yeah, this, yes, works.
So that circuit that you're doing right now, that would always be on. Since you connected the 3v3 into the gate, it's just gonna always be turned on.
Surprisingly, it isn't. I tried it. This actually worked on and off.
Well, it
I'm
will
not
work
here
on and
to.
off as long as you're not providing 3v3 into pin 2, right?
Yes, when
The
I
only
turn
way it's
it
gonna
off,
turn off if you
if I turn this off,
yeah.
this turns off. If I turn this on, this turns on.
Yep.
And that's actually what yeah. And yes, it works. And I hope, I'm really hoping.
And the reason why, if you put a resistor in between the 3v3 or whatever, it's the output for the microcontroller. When you put a resistor in between that and pin 2, it's going to lower the voltage that comes out
Yes, because
of that input. And depending on the threshold, so if your threshold is 1.5 volts, you're sending 3.3, well, the resistor is going to lower the voltage. So you can calculate how much the voltage would lowered, and it's possible that it won't meet the threshold. So
yeah,
that's why your
so
resistor wasn't working in between those two.
yeah, that's yeah, because as I mentioned, voltage divider basically. That's what it is. And especially since I was using 1K resistors in both cases, so it was just dividing it perfectly in half. So half of 3.3 was 1.7, which, funny enough, is right in the middle of the voltage threshold. So it was barely turning on. I was able to turn on the voltage, but the current was negligible. And that's why it wasn't working practically at all. And when it comes to what I meant about like the rules not really applying, the reason why this works, the reason why it turns off, is that when this is sending the current, basically, well, when this is sending this resistor here, doesn't really work like a resistor. It works to sometimes allow this to be a circuit and other times allow this to be a circuit. I don't know if I'm making sense.
It does make sense. It's kind of complicated how transistors work with the source gate.
Yeah, because it's the basically
I'm
always
still
picks the
wrapping my head
path
around.
of least resistance, except the resistance is a part of your calculation. So depending on the path of least resistance, you're working with a completely different circuit. So if we could, for example, connect this cable to this cable with like 1 million ohms, and even though they are technically connected, it wouldn't be it wouldn't, like, there's a limit of resistance where if you have enough resistance, it's just not a circuit anymore. Am I making sense? I don't know if I'm making sense.
Kinda, sorta.
Kind of, sort of. That's good enough for me. That's good enough for my book. Now the problem. Now comes the problem, because this is easy as well. This is just baby mode. Now the problem is, brushless DC motors have 3 inputs, which are also outputs. And what is needed actually from this is, like, when we have 3 of them, just temporarily right here. When we have 3 of them, like so, then when we input voltage right here, we want to output right here. When we input right here, we want to output right here. When we input right here, we want to output right here. And I've seen it. I know how to do it with 6 transistors. That's easy. I was thinking if it would be possible.
It's also called a shift register, right? Whenever you're doing that, that's also a shift register in binary.
I don't.
So if you, yeah, because I was actually looking for a circuit, right? So I was trying to make, let's just say 100 by 100 sensor matrix, but I only had one pin that could read them. Well, what you could do is you could cycle through them, but in order to cycle through them, you pretty much just have to turn on every column or every row. And the easiest way to do that is with a shift register.
That's a component.
So, yeah, it's a component. It's an IC, an integrated circuit that you can get that has all those gates in one chip. And so if you want to regularly do that, a shift register follows that pattern. It's pretty low level stuff. But I don't know why I told you that. I just like, hey.
I mean, it's a cool fun fact. It's a cool fact.
That's what it's called. I know. You can disregard me though. I'm just here for.
Listen, I'd rather get more information than less, honestly. Especially when I'm working transistors.
Let's go off on a random tangent about how to mine silicon.
So basically, guys, speaking of the doping numbers of transistors, you know how many phosphorus atoms there are in a silicon chip? Let me just.
Can I show you something on stream?
Yeah, go right ahead.
I'm gonna turn on my camera because I actually have something that is really cool.
On stream, as an on stream. Can I?
Yes.
There we go.
Yeah.
That's Tefta. Everyone, say hi.
Can you guys see me? Hopefully.
Yes.
Okay. So what I have here, these are silicon wafers. So I literally have silicon wafers, which is really cool. But
wait, what? Why?
Don't ask me. Don't ask me why I have silicon wafers. But,
just, you know what? I get it. It's just one of these things you just accumulate over time.
Yeah.
Oh, there we go. I have something.
As one does.
Can I turn like into an integrated circuit, like a circuit thing? Because we're like a single
what do you mean? Yeah.
Yeah.
So what are you trying to do today? Because right now we have the N-channel MOSFET, so we can actually connect the negative of any component to close the circuit.
Yes.
So with
And
this, what do we want to do
I
next?
can show you the circuit I have in mind, which is, well, the oversimplified version, at least, because I have one circuit which I think should work. And it's a really simple one. I actually designed it before I even got MOSFETs to work. That's how simple it is. So basically, I know I should be labeling them, but it's just like a rough sketch. So we have this, and then we will get some, actually, I'd rather get a switch for this. It's not completely correct, but this is just a sketch. Wait, fudge, switch S. No. What's it called? Like a
Oh, yeah, switch. Are you
button.
looking for a push button switch?
Yes, yeah, precisely. It's not really what
There you go.
will be used, but actually, I technically used. I just realized I did use it when I was prototyping this. I just did it with buttons, and it worked. So
Yeah,
it's tried and tested.
that's a really good way to start.
I made an ESC with buttons. It was way before I got MOSFETs to work, and it was so fun. Just, I was proud of myself. So basically, like this, like this, like this, like this, and then are they gonna go over each other and not connect? Where's the not connecting symbol? Junction. Wait, are they connected or not if I just put them over themselves like this?
Yeah,
I don't
so
think they're
only when
connected
you
because
see a
they don't have
green
a
dot
dot.
are they
Okay,
connected.
yeah. Then
Yep.
there we go. That's wrong. There we go. And this is an ESC, a manual ESC. I guess an MSC, I think.
Oh, okay.
Like we have
So you have plus on one side, negative on the other.
yes, so you basically pick which one you want the positive to go in, and you pick which one you want the negative to go out of.
So you will have 3 N-channel MOSFETs and then 3 P-channel MOSFETs, right? In order to
Well,
accomplish this?
well, that's my
Because you need
problem.
in
I
order
was
to
wondering if it was
yeah, in
possible
order
to
to
do it
connect
with.
the high.
Yeah, precisely.
Yeah, because N-channel is only on the low side, so you can only connect the low side. So switches 1, 2, and 3 would be N-channel MOSFETs. And I don't know this. This is beyond my knowledge, but I'm guessing that 4, 5, and 6 would have to be P-channel
P-channel.
MOSFETs because they're connecting the higher side,
Yeah,
which
that's
would
what I
be
was
routed.
worried about. Because that means I have to buy
But
P-channel
there are
MOSFETs.
integrated circuits that yeah, is this called an H bridge or what is this called? This component?
Oh, I have no clue. This is just like this is a make it ESC.
Ask AI.
But I already know this. So I was wondering if I could actually, if I mean, we could do a fun challenge, which because it technically should be possible to make an ESC with only 3 transistors. Because we only need 3 circuits, so it should technically be possible to make it with only 3.
Yeah. So it looks like it's an H bridge. That's what AI is saying.
Yeah, but that's the original draft, and I was wondering because technically it should be possible with only 3. We have 3 basically circuits. Then we would have to divide into 3 separate circuits, each of them controlled, and so we would basically have 1, 2, 3, and to each one we want to connect a plus of one MOSFET circuit and a minus of another. That's what we want. So out of each one, we want basically like a junction like this, where right here we connect this, and right here we connect this, but of another circuit. Am I making sense? I don't know. So if we have
You are. I like the switch. The switch diagram makes complete sense.
Yeah, the switch,
said,
but
or
that's the easy one
but
with
you need two of those.
right
You need
here.
two of those,
Right
right?
here, I
Because that
think I would just because okay, can I make a custom thing? Can I make like a custom
a
component?
custom what?
Custom
Yeah, yeah, yeah. So just go to place on the menu,
uh
top left menu.
top left menu place.
I think it is. 1 second. Let me find where it's at. Place. And then, oh no, it's under tools and then symbol editor.
Symbol it. There we go. All right. So
So now
basically,
you have to, yeah, this should allow you to create a component.
uh, why the gray has okay. So this
You
is
have to select, you have to hit new, you have to create a new symbol, but it's going to ask you to create a library because you don't have a library. So you're going to have to do file new library,
you know
then
what,
global.
maybe I should just do it like a sudo
It's a,
with wires.
it's a little process. Yeah. It's a little process because you literally have to create a library in order to create a new component.
Okay, so let me just do it the make it way, which would basically mean that's my new component. It's gonna work perfectly and certainly won't be confusing at all. So what this basically would be, to it I would add junctions. So we have the this component will have the input from the pin on the Raspberry. Junction contains no joinable wires and no pins. Oh yeah, I guess that's second just. So it will have the input from the Raspberry to determine whenever it should be on or off. And then it will also have connection to the ground. Am I thinking about this correctly? Connection to the ground, like this would be the ground. And then we would have the negative motor also connected. So this would be the, I should label these negative motor, and then the positive motor is connected to the battery. I see the problem. Wait, or is there a problem? Yes, there is a problem. Or is there? Yes. Yes, there's a pretty big problem. Or is there a problem? Hold on. No, one said okay, I see the issue. I have to buy I have to buy P-type MOSFETs, don't I?
Yeah. Yeah, you're gonna have to have P-channel MOSFETs for the high side and N-channel for the low side. And then you're gonna have to have kind of like a shift register type integrated circuit to take place of those
I don't think I mean for
switches.
each
I
one,
think that allows you to do.
I don't know, for this one I was just gonna connect each of one to the different pin. Because it's 6, it's not a lot.
Yeah, that's 6 for one side of 1/3. Right?
No, I'm not building a drone yet. No. For now, this is near C.
So what do you?
Well,
yeah. So this would only be one output.
Yes,
for
it would only be
side.
one motor.
You're gonna need 2 of those. Well, yeah. So
if I
this
want
is.
to 10,
So let's say you're trying to control one motor.
True. If I want to 10,
you need 2 of those just for 1/3 of one motor. Yeah. Right.
wait, no. This is the entire motor. Because each motor has basically 3 pins. So this is the entire motor.
Wait.
This right here.
Every motor has 6 wires, right?
3.
No, it's just 3. Oh yeah.
Because basically that's why you have them on both sides, because you pick the input and the output wire. So
it's so weird.
It is, right? And it's also
It
genius.
Is so weird. I'm not used to that.
Yeah, and it's also pretty genius.
That's.
I mean, I am honestly.
This is why I don't like AC. Like it is AC is crazy, especially when you're doing DC circuitry to try to emulate AC. That's why they make like DACs and digital to analog converters.
Yeah, but this
But you
is
have to switch the polarity
but
because you have to go below 0, which is just so weird.
I am just really I'm just really amazed with this because what basically happens here is like you have a coil, right? You have coils. Uh,
Yeah.
you have the motor, like let's say like this, and all of them are just connected to it. All of them are connected to a different set of coils. And then all of these coils are connected. So the current goes in, moves through the coil, and then it goes through the coil that completes the circuit. That's why there's only 3. And so if this one is connected and this one's connected, it would go in through the coil, and it would exit only through this one because this one isn't a closed circuit. It can't go anywhere this way. That's why we only go through this coil. And that's really smart in my opinion.
That's crazy.
Yeah, so I need to buy P-channel MOS. Wait, do all the MOSFETs have like their own P counterparts, or do I need to genuinely look for a new one?
I don't know the answer to this because I have to look at other schematics. So what I do is I'm not familiar with an ESC is quite difficult. I would look at the circuitry of another ESC.
Yeah, that's how I got the idea. Wait, that is true. When I wait. The reason why I got the I got the idea for using N channels as an ESC from the one you sent.
Yeah, let's take a look at that.
Wait, let me find the message. It was on Patreon only chat. There we go. This way, this way. I've got some news. Hold on. No. Where was the? Oh, where's that message? You basically was a link to someone.
I found it.
You found it, alright? Oh.
Found one.
In Patreon. In channel Patreon. Channel and HTTPS. It was. I can find it. As you already sent it here.
I sent one.
Oh, that's okay. Damn, I send a lot of GIFs. Or GIFs. It'd be so much easier to find out I didn't send this.
Here we go. Here's the one that I kept on sending. This is the one we were looking at.
Wait, let me just go through yes, that's actually precisely the one I was looking for right now. Yes.
Okay.
I found another
good.
one, but yeah. And right here, the parts. Oh goody. Wait, there's are two.
So they have.
Wait, where are the MOSFETs? That's the MOSFET. This.
It looks like it, yeah.
It looks like 2 N channel. That's witchcraft. Oh, but it's using a. Okay, that's why it's 2 N channel. I see.
Why is that?
Because of all of this, they have them because right here.
Yeah.
Yes, you have 2 different pins to control each bridge of the ESC, and then yeah. So for me, I will need a.
Oh, so the bridge takes care of it.
Yes, and the MOSFETs. So these MOSFETs are here for the electrical reasons, not the electronic ones. Hey, make it. This is for you, Chucky. Nice. pretty sure it's witchcraft. It is witchcraft. They don't exclude each other. But hold on. Another thing which I found is this. Which uses 6 N-channel MOSFETs. Huh. And that's actually precisely the circuit that...
Yeah, because maybe you could use those in a way that I'm not familiar with. That's why this stuff does seem kind of magical.
Can you imagine if MOSFETs were this simple? If you could just plug them in and they would just walk? Can you imagine?
That would be crazy.
If you could just plug them in and you wouldn't have to deal with...
Plus and minus. Yeah. Just plug a battery in, the motor turns. How fast? However fast it wants to.
Like this motor shouldn't even have 3 cables, it should have only 1.
Yeah.
You just pump in the electrons.
Yeah, just look at the motor, and the motor will read your brain and know how fast to spin, and it will sap energy from Jupiter's orbit and spin.
Honestly, not even like a motor. It's just like a cube. You look at it and it just does what you need it to do.
Yeah.
People should reinvent that sort of thing. There's a market for that.
Yeah. Science is magic.
But wait, okay, let's... But these are all... Wait. Wait a second.
Yeah, but some are on the high, some are on the low, right? So how... They're creating like this weird thing where you have some on the top, some on the bottom, which is weird. Oh, okay. So the PWM1, PWM2, that's the pulse width modulated signal. So yeah, that is coming from the microcontroller. All those gates are listed. PWM1, PWM2, 3, 4, 5, 6. So that's where the microcontroller is telling, is connected to the gates.
Wait, so hold on. I'm understanding this correctly, right here. Because I mean, wait, wouldn't N-channel MOSFETs work in this case actually? Because
I do not know.
I don't know. You are using them to get current on this side. That's why you're using N-channel MOSFETs. But also
connecting the ground,
in the saturation mode, the difference between the saturation and the off mode is also the resistance right here, which means if they are on, you will get voltage through. If they are off, you won't. So I feel like this could work. I'd have to try it, but basic idea of goodness is gonna be so fun to modify.
We'll make some coffee. I'll be right back. I do have to leave in about 20 minutes, 15 minutes
Don't
for
worry,
my
I know
coffee clicker.
Alright. Just move these in the meantime. Very quickly. Okay, this is gonna be a mess. But don't worry, so am I. Yes, I'm a mess with an S on my chest. If some of you all got that reference, then I'm impressed. Let me just delete all the text. It's kind of cluttering it all up. Alright, and now what we need? I'm just doing sleep gives me the existential crisis. You're doing a great job of hiding alien ships, I've gotta say. This connects the third one. Can I make this like smaller? No. Why? It's fine though. Okay, we can. Just this side. There we go. Now this a bit further too. And now move all of this a bit further down. All of this, but actually just all of this a bit further up. Actually, just all of this a bit further up. There we go. Give some space to breathe, and then the resistor. 3, right? If I remember correctly, 3 to the third one. So we need. Right here, and then they are just both connected to the. Okay. There we go. This should be. Ah. Have to find them. And then each one will be just a label of in 0, and then in 1, and then in 2, and then in 3, and then in 4, and then in 5, and then I think this should work. I don't know. I'm gonna make dumplings. You wanna join? Oh, I love a dumpling. I'm gonna just wait for Tef to come back, and I'm gonna have the teacher review.
Is it working?
I don't know. I haven't built it yet. I will build it right after the stream. But this is what I have in mind. Basically.
Okay.
And this looks smart, right?
Yeah.
And it's a rule. If something looks smart, that means it is smart. And that means it works.
Yeah, and so what you have is the PWM signal that's mimicking the AC current, high and low for each 3. Okay. Yeah, that looks good. That looks like the diagram that you sent. I don't know how N-channel MOSFETs will operate in this.
Neither do I. This is not gonna work. There's like we can go on record right now. This isn't gonna work.
You really need an oscilloscope in order to measure this.
It's expensive.
I know. That's why you need your PO box so I can send you one.
I do need a PO box. I'm gonna be moving.
How long have I told you to get a PO box?
I know.
I offered to send you stuff.
You know, I might open up one.
See, because I need to give you my old oscilloscope because I need a new one.
Listen, how long have I told you to set up an open muscle donation link?
Equally as long.
See, we both want to give each other money. It's not fair. I'm gonna be moving in like a month or 2, and I just don't want to set anything up in my location because I have this thought in the back of my head that I will move soon, and so.
And then you can rearrange things.
Yeah, and I don't like temporary things, but that's the same reason why I'm right now, for example, not setting up a lab. My office, I could just turn it into a lab, but I'm not doing that, or like a more permanent workshop. But I'm not doing that because I just have this thought in the back of my head that I am gonna move in a month or 2. So.
I like the name. There is no escape, but people can't see it on
I know.
stream because my logo.
Yeah. It's actually the original one. Remember the last time I was trying to make an.
That's funny.
I like naming stuff fun. That's why.
So this is actually you've broken it down to something manageable. So you have now you just need to send the PWM signals through 6 pins.
Yeah,
This
actually,
is doable.
my idea is different. I'm gonna text my idea right now in the Patreon channel because I really don't want to share it publicly. Originally, I obviously wanted to make a drone. That's yeah, that's
Intellectual
obvious.
property.
But
That's why he's not sharing it.
yeah, I don't want any of y'all to steal it. I mean, I would have to then sue you if you even listen to it. I have to sue you. It's a whole thing. But like, this is what I want to make.
Nice.
Yeah.
Yep. He's typing the secrets of the
Oh
universe.
yeah, I'm typing. I'm actually meaning of life.
It's so beautiful. I've never thought of it in that way.
Yeah,
It's so
and
succinct.
actually Einstein was so wrong, right? Like the fact that Einstein didn't think of that. The relativity. Why not go for the theory of everything? So simple. But yeah, that's basically my idea. It's much more manageable than the drone, and
Yeah.
honestly, I kind of like it. I kind of like this idea, and it also gives me a nice excuse for why, I shouldn't make this too complex
Yeah.
because it eventually won't really matter. Like for this one, I don't have to make it too complex. So it gives me a really nice excuse to not try too hard, to not do the actual work required, which I love. I love it. I love it. For everyone else, when you're actually uh, doing electronics and electricity right, then for example, with something like this, especially with stuff like these, you would want like a separate circuit to make sure that the voltage is constant that's going in. You would with capacitors and resistors, you would want redundancy. So you would also want to check in some way in what position the motor is currently, because otherwise it's not gonna be as it is gonna work, but not as efficiently and stuff like these. But I don't care.
Yeah.
I'm not doing it to be good. I'm just making it happen. Well, I won't be holding you any more hostage there after.
Well, we're gonna work on the coffee clicker thing today.
Yeah, but I
So
feel
that'll be
like
fun.
I feel so silly with like this is my big project, and you just casually, as a fun side thing, just to make sure that people don't have to interrupt each other, just doing something 10 times more complex.
It uses this N channel MOSFET, and I had that same exhilaration that you did, like getting that to work. It then allows me to make so many other projects. But that's what's so cool about electronics is once you can do a few things, you can get more and more complicated.
Yeah,
And it actually is pretty exciting.
once you have a working MOSFET, you can basically control anything you want.
Yeah.
This is a huge step. I'm I mean there is like a limit to it because you do need different MOSFETs for different things. And yeah, I'm saying MOSFETs because no one uses BJTs to control stuff. They use BJTs for weird reasons. They use BJTs for the same reason why people use capacitors.
I use vacuum tubes. What are you talking about?
But have you ever? But have you? I'm so terrified. I'm so terrified of BJTs and capacitors because they're both used in the same way. They're like used to modify the current and voltage in different scenarios. And so basically, for example, when you want to make sure that the voltage is always the same when it goes in, you use capacitors in a certain way. But it's so confusing. It's so unbelievably confusing and so difficult. Have you ever actually used the BJT?
No, I've not used a BJT, but I have worked on projects that include inductors, and those are fascinating.
Wait, inductors? What are those?
Yeah, inductors, they're like capacitors. That's what I thought you were talking about until I looked up a BJT, because that's just a transistor bipolar gate. But an inductor it has like a ferrous ring, and it's like a toroid electromagnet. And electricity, it has high resistance as it's going through, and then it's quote unquote charged up. It's the equivalent of a flywheel in mechanical engineering. A flywheel has inertia and it's spinning, and so even when electricity is stopped applied to
So
it,
it's
it still is
basically
spinning to produce electricity,
so
so it'll
inductor
still
is
shove it through.
basically like what people think capacitors work like. Like,
Exactly.
yeah, if
Yeah.
someone was explaining what
Exactly.
capacitor looks like, that you would think of an
Yeah.
inductor. Okay,
An inductor,
that's
exactly.
a
And
that's a
then when
phenomenal definition, actually.
yeah, and inductors are kind of cool because you can use them in circuits to like do some fun stuff. But anyways, I've not used a BJT before, and
Yeah, because BJT, from what
transistors
I
are
understand, BJT is
yeah.
like a MOSFET, except you use current to control it.
Oh,
Which is, if you think, the longer you think about it, the dumber it gets. You,
yeah.
what possible scenario you could have in which you use current to control voltage?
It might be that it's like a sensing. If you're gonna build a electronic sensor, like an analog one,
Where it
you would probably use a BJT
where it
because
is used is it's used basically inside circuits, not as electronic component or but like an electric component to level out the currents to basically,
uh,
when you're doing resistors, you're messing with voltage most of the time, and when you're doing BJTs, you're most of the time messing with currents, except in much more complex ways. So, and by the way, as a bit of a backstory, whenever for everyone who isn't into electronics, all the microcontrollers, they all output high voltage, low current. The reason being is just easier, for lack of a better word, to do it, and you don't wanna, and they are supposed to do logic, so they're very delicate. So you don't wanna pump too much
they're
power to
dainty.
it. Yeah. My Raspberry Pi Pico overheated today, but still working, so I'm impressed, honestly. The fact that I could overheat it just still working, that's impressive.
The
Anyhow,
little engine that could.
yeah.
Well, see you later, make it. That was a fun
Well,
stream.
bye, Tefta, bye. I just realized we haven't designed the PCB. We get back to that. Well, you know what? A circuit's good enough. So I'm gonna go now, everyone. I'm gonna go walk on the videos, all the different ones. Oh, look how cinematic, look how aesthetically pleasing this shot is. Just big make it in the middle. Oh, that's a really nice one. Oh, I'm really made this model pop, didn't I? That's solid. Well, anyhow, I'm gonna go now. I have a video to make. I have 2 videos to make. I have 3 videos to make. One isn't even for my channel. And I have 4 videos to make about the thing we did today. So, thank you everyone so much for watching. And have a great day. Bye.